Let's tackle a harder problem using integration by parts. Here I've got an integral, which is the product of two different functions. I cannot use u substitution because the derivatives of these functions are not related to one another. Now, whenever I do integration by parts, I need to make sure that the new integral that I get is not any worse than the integral I started with. So for this problem, I'm going to pick u equals sine of x, dv equals e to the x dx, and the rest of my table falls into place. Derivative of a sine is the cosine function. So a single du is equal to a cosine of x dx. And the antiderivative of e to the x dx is just e to the x. Very nice to work with. My integration by parts formula tells me that my old integral will be equal to the product of u times v minus the integral of v du. Let's go ahead and fill in that recipe card. U times v is the sine of x times e to the power x, and I subtract off the integral of v du, which is e to the power of x cosine of x dx. Well, that integral isn't worse, but it's also not better. I just swapped out one of my trig functions for another one. What I can do in this case is I'm going to do integration by parts another time. Well, why would I do that? I've done it once already, and I had a function pop out minus an integral I still need to solve. If I do this a second time, maybe I can turn my cosine back into a sine, so I'll have integral that I want to solve for equals stuff, plus some more stuff, plus that same integral that I want to solve for. So if I have an unknown integral on two sides of an equation, maybe I can use some